right, welcome to homework help for the Unit 8 review. Here we go. So, find length of C by using the Pythagorean theorem. All right. So your Pythagorean theorem is a squared plus b squared equals c squared. All right, so this one they tell us. So a is 5, so that's 5 squared. So I'm substituting 5 in for a plus b squared. B is 12, so that's 12 squared. Whatever this is will be equal to c squared. Okay. Let me change the font. I really don't like. There we go. Now we're just simplifying. So now 5 squared, 5 times 5 is 25, plus 12 squared. 12 squared, that's 12 times 12. 4 equals c squared. Okay, you're going to add these up. So you have 25 plus 144. So you get 169 is equal to c squared. And then your last step, don't stop here. You're not done. Your last step is to take the square root of both sides. So that cancels out your squared, so you get c equals the square root of 169. And that actually is a perfect square. It's 13. Okay, so c equals 13. Another way to think about this is the distance from whatever this point is, from this point to this point, the distance, the length of this line is 13. All right, so c is 13. Number 2, same thing. Find the length of c by using the Pythagorean theorem. Let me just copy it down here. Okay. So this one, they don't label, so you can pick. I always make my shorter side a. So I'm going to make 4 be a and 6 is b. But you can do the other way around if you want. So I'm going to do 4 squared. And we're back to this font that I don't like. Plus 6 squared equals c squared. Okay. 4 squared is 4 times 4, which is 16, plus 6 squared, which is 6 times 6, which is 6, equals c squared. Right, and then you just add those guys together. So you get 16 plus 36, which is 62. So 62 equals c squared. Okay, once again, you're not done. You have to take the square root of both sides. So when you do that, you get the square root of 62 equals c. So c equals the square root of 62. You can leave it there, or you can change it into a decimal. Wait, no, I'm sorry. That's not. I think I added those wrong, didn't I? I did. Sorry. My bad. You're not going to get 62. I can't add. Okay, let's see. 36 plus 16. 52. I added on an extra one. My bad. This is 52. So the square root of 52 equals c. If you want to change it into a decimal, I don't know. Let me do it. The square root of 52, it'll be 7 point something. 7.2 is good enough. Which is equal to 7.2. All right. So the length of this side is 7.2, or you can leave it as the square root of 52. Okay. Oop. Moving on to the next. In a right triangle, A and B are the legs. Okay, so A and B are the legs, and C is the hypotenuse. You need to remember this word. Hypotenuse. C is the hypotenuse. It is your longest side. It is the side across from the right angle. Here's the right angle, here's C. Here's the right angle, here's C. So it is the side opposite of the right angle. But actually, yeah, I do want you to remember that for future references, but it is the longest side. All right, it's called the hypotenuse. That's all I want you to do for number 3. Number 4. Okay, so number 4 has A through D, I believe. Yes. So you're looking at this quadrilateral, W, X, Y, Z, and you have to say, is it a parallelogram? Is it a rhombus, a rectangle, a square? Why or why not? And you have to prove it either way. So if it's not a parallelogram, you have to say why. If it is a parallelogram, you have to say why. All right. So you need to figure out the following information. You need to figure out, are the opposite sides parallel? Okay, you need to figure out, to be a parallelogram, are the opposite sides congruent? So basically, we're going to find, find slopes of all four sides. Okay, you're going to find the slopes of all 4 sides, and 2, you're going to find the length of all 4 sides. Once we figure out that information, we can answer A through D. Okay, so whenever you're asked to prove if a quadrilateral is any of those things, you can just figure out the slopes of all 4 sides and the length of all 4 sides, and then we'll answer the questions. Okay, so we're going to find the slopes of all 4 sides first. You could also find the lengths first, it doesn't matter, but I'm going to do the slopes first. Okay, so let's go with WX. All right, so I'm focusing on this line right here. What is the slope of this line? I can't draw on this, can I? Not easily, okay. My change in Y, I go 1, 2, 3. I go up 3. From W to X, I go up 3. 1, 2, 3. So that's my change in Y. So it's 3 over my change in X. I go over 3. Sorry, I go up 3 and over 1, 2, 3, 4. Over 4. So I go up 3, over 4. That's my slope of WX. Okay. Oh, me so little. There we go. And let's make this not. I don't know what I have against that font. Okay. So that's the slope of WX. Let's find the slope of, okay, so its opposite side has to be parallel. So WX, this side, has to be parallel to this side. So let's figure out the slope, and that will tell us if they are parallel or not. Oh, sorry, 1 second. Nope, we're good. So, oh, not XY, I'm sorry, ZY. Goodness gracious. WX needs to be parallel to ZY. Why do I keep saying X? WX, ZY. Okay. So my change in, what's my slope of this line right here? Let's see, I'm going up from x to y. I'm going up 1, 2, 3. I'm going up 3. And I'm going over 1, 2, 3, 4. So I go up 3, over 4. So they are, in fact, the same. They have the same slopes. So these two lines are parallel to each other. We just proved that by finding the slopes. Parallel lines have the same slopes. These have the same slopes. They are parallel. They are parallel because they have the same slopes. Okay. We're not done. Now we have to figure out the slope of, let's do WZ. WZ. So what's the slope of WZ? This line right here. Well, it's slanted down, so it's going to be negative. So let's see. We're going down. How many? 1, 2, 3. Down 3. So negative 3. 1, 2, 3. Wait. 1, 2, 3. Oh, okay. We're going from 1 to negative 2. Yep. So we're going down 3, and we are going over how many? Over here, we're going over 1, 2, 3, 4. Going over 4. Down 3, over 4. Okay. So then WZ has to be parallel to XY. Let's see if it is. Or is the slope of XY? If it is the same, then they are parallel. If the slope is the same, then it is parallel. So I'm going down 1, 2, 3. Go down 3, 1, 2, 3, 4. Okay, yep. I go down 3 and I go over 4. Once again, these sides are parallel to each other because they have the same slopes. Okay. So to be a parallelogram, let me see if I can bump this down. There we go. We have to have opposite sides parallel. So yes, that is true. Opposite sides are parallel. We just proved that. Okay, they have the same slope. Right? Also to be a parallelogram, opposite sides must be congruent. We need to figure that out. So are all these sides the same length? So this is where you can use your distance formula. So here we're on number 2. Find length of all 4 sides. Oh, where'd we go? Where'd we go? Oh, he got mad at me. Okay, that's fine. We can be down here. Would be equals square minus x1 plus. Okay. So you can substitute in the points, or stay with me. We just found the change in x and the change in y. We just found all that. Okay. So insert equation. D equals the square root. Okay. So let's find wx. We'll go in the same order. So wx, my change in x. What was my change in x for wx? 4. So my change in x is 4. Oh, I need to put it in parentheses. Hold on. Plus, what was my change in y? My change in x was 4. My change in my change in y was 3. So that's 3. So d equals 4 squared is 16 plus 3 squared, which is 9. Oh, it's going to come out nicely. Wow. Okay. So d equals the square root of 16 plus 9, which is 25. Okay, which is equal to, the square root of 25 is 5. Right. So there. Actually, I'm going to go ahead and just write the distance up here. So that's our slope, and then Wx. No. Wx is 5. All right, we just found out the length between this and this is 5. We found that using our distance formula. Okay, so now you're going to do the same thing for zy. Is zy going to be the same length as Wx? So here's your distance formula. If you want to do it substituting in the points, let me do it that way. Okay, so we're going to find, what did I just say, zy. We're going to find the length of zy. So if you want to do it with the points, let's pull out the points. So z is 1, -2. 1, -2. Y is 5, 1. Y is at 5, 1. Okay, so we're trying to find the distance between these 2 points. I'm going to make this be my, this is going to be my x2, y2. Okay, x2, this is going to be my x2, y2. I can label it. Make this the x. So this is x1, y1. X1, y1. Okay. Anyways, so x2 minus x1. So that's 1 minus 5. 1 minus 5. 1 minus 5. Okay, squared. Plus y2 minus y1. So y2 is -2. -2. Minus y1 is 1. 1 squared. Okay, so we just substitute it in. I substituted in 1 for x2 and 5 for x1. And then over here, I substituted -2 in for y2 and 1 in for y1. All right, that's how I got this. Now you're simplifying again. So d equals the square root. 1 minus 5. 1 minus 5 is -4 squared plus -2 minus 1. Please be careful with your signs. -2 minus 1 is -3 squared. Then we just keep on going. -4 squared is 16 plus -3 squared is 9, which equals the square root of 25. Okay, so you get the same thing, which is equal to 5. Right, so these have the same length. So that was zy is 5. So these sides are congruent. Whew, we're almost done. Now we have to figure out the other two sides. So WZ and WZ and XY. We have to figure out the side lengths of these guys. All right. So let's do WZ. WZ. Okay, you can either do it the way we did the first time, where you just substitute in the change in X and the change in Y, or you can do the points. So we'll do the points. You can skip through me if you know how to do this, obviously. So W, no, I'm get rid of that. W is at -3. Wait. Yeah, WZ. So I'm at -3, 1, -3, 1. And Z is at 1, -2. Choose which one do you want to be X1 and Y1? Let's make actually it's fine. This can be X1, this can be Y1. And then this is X2, Y2. Okay. So you're just substituting in. So D. Oops. D equals. Okay. X2 minus X1. So that is 1 minus -3 quantity squared. Once again, be careful with your signs. 1 minus -3 changes to 1 plus 3. Squared plus y2 minus y1. So y2 is -2 minus 1. Make sure I did that right. That would be x2, so it's 1 plus 3, and -2 minus 1. Okay, sweet. Equals brilliant. Okay, 1 plus 3 is 4. Actually, I'll just write it out. So that is 4 squared plus -2. Oh, I forgot my squared over here. Squared. No, not the thing. Okay, actually, that's fine. 4 plus this. -2 minus 1 is -3. Four squared is 16 plus -3 squared is 9, which equals just add those together so you get the square root of 25 again, which equals 5. All right. We did, that was WZ. 5. And then the last one is XW. Or XY. Goodness, letters. XY length. Okay, so, or ZY. XY. What am I doing? I'm doing XY. XY. We just did WZ. So X, Y. X is at, get your coordinates, so X is at 1, 4. Y is at 5, 1. Okay, all right, I'll just keep them labeled this way. So this will be X1 and Y1. This will be X2, Y2. Since that's all I have. That's already how it is. Insert equation. This is taking forever. Okay. X2 minus X1, so that's going to be 5 minus 1 squared. 5 minus 1 squared plus y2 minus y1, so that's going to be 1 minus 4 squared. 1 minus 4 squared. So then that is D equals square root. 5 minus 1 is 4. less 1 minus 4 is -3. Four squared is 16. -3 squared is 9. Again, so you get equals. Add them together, square root of 25, which is equal to 5. Woo! Thank goodness, done. So, opposite sides are in fact congruent. They're all congruent to each other. So, yes. So we have a parallelogram, and we just proved it by finding the lengths and the slopes. Okay, that's fine. Now, next one is, now this won't take, now we have all of our information, so now this won't take so long. Is it a rhombus? So to be a rhombus, opposite sides have to be parallel, and all sides must be congruent. So are those true statements? Are opposite sides parallel? Well, yes, we already proved that. Yes, opposite sides have the same slope, so they're parallel. Are all sides congruent? Are all sides congruent? Are they all the same length? Yes. We just found all the lengths, and they're all the same length. So yes. So yes, it is a rhombus. Right? Rectangle. To be a rectangle, you need sides parallel, sides congruent. Okay, so it's a parallelogram plus all right angles. Okay, so are opposite sides parallel? Yes, we proved that already. Are opposite sides congruent? Yes, we proved that already. All sides are congruent. Now hold on. Do we have all right angles? Let me scroll back up here. So that means in order to have all right angles, my sides would have to be perpendicular to each other. Okay? So WX would have to be perpendicular to WZ. So is WX perpendicular to WZ? This is where you need to know your perpendicular slopes. Okay. So if I was going to have a line perpendicular to WX, it would be you switch the sign and you flip it. So I'm going to flip it, so it's 4/3, and then it would be negative. That is the line, that is the slope that would be perpendicular to this line. That is the slope that would be perpendicular to this line. So does that match? Does that match? So is WX perpendicular to WZ? Are these two lines perpendicular? They are not. It's close. They switched, the sign is switched, but these would have to be flipped. It would have to be -4/3. It would have to be -4/3. Okay? A slope perpendicular to ZY, same thing, you would flip it, so it'd be 4/3, and then you would change the sign. Okay? These slopes do not match these slopes. So these lines are not perpendicular to each other. These lines are not perpendicular to each other, which means they do not form right angles. So these do not form right angles. It's close, but no. No. Slopes are not, they're opposites, but they're not reciprocals. Let's say that. So, therefore, not a rectangle. So far our shape is a parallelogram and it's a rhombus, but it is not a rectangle because we do not have all right angles. Woo! Square. Oh boy. So a square has to be both a rhombus and a rectangle. So opposite sides parallel. Sides congruent. Congruent. So it would have to be a square, it would have to have these three things. Okay. Are opposite sides parallel? Yes. Are all sides congruent? Yes. Do we have all right angles? No. Therefore, no. Therefore, not a square. Okay. So once you figure out, and we're done. Whew. So once you figure out all the slopes and all the side lengths, you can prove all of these things using that information. Woo! Woo! Okay, number 5. Find the distance, I've been staring at a screen for too long, between the points 18, 9 and negative 4, 13. Alrighty. So you're going to use find the distance between the 2 points, distance between points, distance formula. Let me see if I can just copy it down here. Did I erase it? Okay, that's fine. Insert equation. Okay. So my distance formula, change in x, x2 minus x1, quantity squared, plus. Okay. There we go. We're just going to fill this bad boy in. I'm going to make. This is going to be x1, y1. Okay, this is x1, this is y1. So then this will be x2. Okay. Here we go. We're going to fill it in. X2 minus x1. So that's negative 4 minus 18. Negative 4 minus 18. Squared. Well, I didn't mean to do that. Oh no, oh no. What's with me? There we go. Plus y2 minus y1. So y2, 13 minus 9. 13 minus 9 squared. Not the note from around it. Okay. So then I have negative 4 minus 18. Negative 4 minus 18 more. So we're going to get a bigger negative number. That is negative 22. Be careful with your negatives. Squared plus 13 minus 9. Mm-hmm. 22 squared, or negative 22 squared, is 22 times 22, 484. So negative 22 squared is 484, positive 484. Your negative is gone. Your negative is gone. Negative 22 times negative 22 is a positive number. Okay? I did it again. Plus, okay. 4 squared is 16. Then we just add those guys together. So 484 plus 16, oh, wow, is equal to 500. Okay. So the distance between these 2 points is the square root of 500. I'll take that if you leave it right there. If you take the square root of 500, 22.36. Sure, 22.36. Okay, so that is your answer here. Either one of those is fine. So the distance between these 2 points is 22.36, or you can leave it as the square root of 500. Okay. Okay, these are going to go faster. We just stopped proving one that was long. Vertical translations. Similar to what we did in class today, okay? If f of x equals g of x minus 7 and g of x equals 2x plus 10, then we need to write the equation for f of x. So this is when you're going to use substitution. So g of x and g of x. So we're going to substitute 2x plus 10 in for g of x. So then you get f of x equals Substitute it in. 2x plus 10. Okay, and then rewrite your minus 7. Minus 7. And then you just simplify that. Okay, 2x, and then you have 10 minus 7, which is 3. All right, and that's your answer. Okay, the next one, f of x equals g of x minus 2, and we're given g of x. So we have to write the equation for f of x again. So make sure you're pausing me and trying these on your own. So once again, we're going to use that substitution. G of x is equal to negative 3x plus 5. So we're going to substitute that in. So f of x equals g of x, substitute in, negative 3x plus 5. And then don't forget to rewrite your negative 2. Minus 2. And then you just simplify. So f of x. The slope stays the same. So you still have negative 3x, and then 5 minus 2 is 3. Ooh. Plus 3. So if we're thinking about these in terms of a graph, f of x is 2 lower than g of x. F of x is 7 lower than g of x. So the graph is getting translated down 7. This graph's getting translated down 2. Okay. Wait, that didn't work. This was a negative 5. That's why that didn't work. Sorry. Negative 5 minus 2 is negative 7. Hold on. Yeah, be careful when you're writing your sign. So it was negative 3x. Did I really write plus negative 5 there? How irritating me to do that. I'm going to change that so that it just says 3x minus 5, because what the heck was I doing? Okay, there we go. But, so g of x is negative 3x minus 5. Goodness, minus 2. There we go. So that's still your answer. All right, number 8. F of x equals g of x plus 10. And we're given g of x, so use your substitution. We're going to substitute in this for g of x. 7x minus 2, and then plus 10. Gotta rewrite your plus 10. 7x, and then that is negative 2 negative 2 plus 10, negative 2 plus 10, which is 8. Plus 8. And that would be your final answer. All right. That's going to bother me. Let me go fix that. I have to pause you just for a second. Sorry. Okay, we're good. Anyways, number 9. If f of x equals g of x plus 3, and then they give you g of x, so don't let it freak you out that now you have an exponential equation. Same process. All right. We're going to substitute this in for g of x. G of x is equal to 2 times 5 to the x, so we're going to substitute that in for g of x. So f of x equals 2. Oh. Here, I'll just copy it. Okay, and then plus 3. Plus 3. And that's your final answer. Just leave it there. You cannot combine anything together. You leave it there. You can't combine anything together. Oop, I have 2 equal signs. There. Leave it. You're done. So this graph is being shifted up 3. Being translated vertically up 3. All right. We're almost done. We're almost done. Number 10. Write the translation form equation shown by the table. Okay, remember that translation? Oops, that translation form. I'll just write down here. Okay, where K is your vertical translation. Okay, well, what's happening? My x values don't matter right now. We're just looking at from f of x to g of x. How much am I shifting? From 9 to 5, I'm going down 4. From 12 to 8, down 4. From 15 to 11, I'm going down 4. From 18 to 14, down 4. So from f of x to g of x, I'm going down 4. Okay, so g of x is equal to f of x minus 4. That's all you need to put there. Ta-da! Where it's okay, your vertical translation is -4. F of x to g of x, I'm going down by 4. 9 minus 4 is 5. 12 minus 4 is 8. 15 minus 4 is 11. 18 minus 4 is 14. All right, so that's your answer for that one. Moving right along. Number 11, same thing. Write the translation form equation shown by the table. So from f of x to g of x, what's happening? We are going up 5. From -5 to 0, that's plus 5, plus 5. From -7 to -2, that's plus 5. -7 plus 5 is -2. -9 plus 5 is -4. -11 plus 5 is -6. So your equation here, f of x, and this time we are adding 5. So that means g of x, the graph of g of x is going to be 5 above f of x. It's going to be 5 above. It is being translated up 5. All right. Number 12, last one. Oh, wait, hold on. Let me highlight it. There. And then finally, number 12. Given the translation form equation right here and the graph of f of x, graph g of x on the same grid and write the slope-intercept form equations for both. Okay. So I'm given my graph of f of x. So g of x oh, that's not how I wanted to write that. Okay, well, let me think if I want to do that to you. I don't. I'm going to change this one too. Get rid of my circle. Let's make this g of x equals, there we go, -5. So then, this is our f of x graph. So then our g of x graph is just going to be 5 below. So we're going to move this whole line down 5. Okay? So you can pick any point to start with. I like to start on the y-axis, so I'm going to move this down 5. 1, 2, 3, 4, 5. So I'm going to have a point there. Down 5, where's another point? Where did it hit exactly? Ooh, it's kind of annoying. So I guess right here, so down 5. 1, 2, 3, 4, 5. Okay. And then, oh, it hits right here. So down 5. 1, oh. Oops. Down 5. 1, 2, 3, 4, 5. Boom. Okay, and then you would connect those with a line. There, and there is your g of x line. Now we have to write the equations. So f of x, just look at your line. So what is your slope of f of x? It's hard to tell if it hits that point or not. I don't think it hits until right there. So I'm going to go 1, 2, 3. So I'm going up 3 and over 1, 2, 3, 4, 5. Up 3 over 5. So my slope is up 3. No. Go up 3, and then I go. Well, actually, we'll go the other way. Sorry. So we're gonna go down 3, then over 5. Down 3 over 5, and then my y-intercept is 2. Boom. Then g of x is just f of x minus 5. So your slope's the same. Okay. And then you're just subtracting 5. So 2 minus 5. And that checks out. Your y-intercept is, in fact, at -3. Whew. There you go. And you are finished.